Welcome back to Arduino Ninjas. In our previous exercise, we learned how to make an input be read by the Arduino, and we used that to turn an LED on or off. We're actually going to use exactly the same circuit. So if you haven't still got that set up, go back to the previous video and have a look. Make sure it's got the pull down resistor on it though. So just so that you can see that, I will fade across. And if you remember, we had an input coming from the switch to pin 2 down the orange wire. The other side of the orange wire was connected to 5 volts. Sorry, the other side of the switch was connected to 5 volts. Then we have this 10 kilo ohm resistor, brown, red, black, black. Sorry, brown, black, black, red, running between the signal wire, the orange one, and ground, this black wire. On the other side, and this is less important for what we're going to do today, we've got a wire coming from pin 3 to our LED, through the LED, through a 220 ohm resistor, and back to ground. So we're going to use that circuit again today, but before we do, let's jump across to the Arduino code, the Arduino IDE, and let's see where we were at. So if you remember, this is the same code we had last time. The switch, SW, is defined as on pin 2. The LED is defined on pin 3. What we're going to do this time is we're going to modify our code. In fact, we're going to modify our loop, so I'm going to delete that for the moment, so that it can count the number of button presses. We're actually going to put that result out through something called the serial monitor. Now, your Arduino Uno is connected via USB. USB is there to power it, it's there to program it, but it's also there to send and receive data. So up here in the top right, we have something called serial monitor. If we press that, it opens a window at the bottom. This is called our serial monitor. We are going to be able to send and receive messages through this monitor. We can send things through the black box, and then the data will come back in this gray area down here. We actually have at the end an ability to set what's called the baud rate. That's the baud rate is how much data gets sent per second. We're going to make sure this is on 9600 bits per second, and we'll leave that there. It's going to be useful to just remember that number. So to be able to use the serial connection, we need to go up to our setup code. So far we've got the output, the LED set as an output, and the switch set up as an input. But we also need to tell it that we want to begin what's called serial communication. So that's serial with a capital S, E-R-I-A-L, dot, and we want to begin transfer, B-E-G-I-N, lowercase b. What we now need to do is tell it how fast we want to send the data. You can go up to 115,200 bits per second. However, 9,600 generally works really well. And what we're going to do is we're going to now write after that serial dot print line. Print line is literally going to send a line of data to the screen, and we're just going to send a message. Serial port is ready to send. You can put anything you want in there, as long as it's encapsulated with quotation marks. Then it will print to the screen. Now, if we literally press verify and upload, if we go to the serial monitor, serial port is ready to send. It's gone through pin mode, started the serial connection, and it's printed out that message. And now it's going around the loop, and there's absolutely nothing happening in the loop. So we're going to make it count when we press our button. So we're going to need a variable, a global variable. So we're going to put it above the voids, above setup, above loop, outside all the functions, but below the macros. And we're going to need a number. And if you remember, what we do is we use an integer or an int to store a number. And I'm just going to call this one count. And I'm going to make it start with a value of 0. So int count equals 0. And then in our loop, we're going to take what we had before, if digital read of the switch is high, then, well, let's make the count go up by 1. So that would be count equals count plus 1. Alternatively, we could also write count plus plus. Either one of those will work. I'm going to leave the top one in for clarity. So the bottom one, I'm just going to comment it out. Remember, 2 slashes allows you to comment it away. And then let's just print to the serial line what the current value of count is. So serial dot print line, print ln, count, count, count. There we go. Helps if I spell it right. Serial.println count. If we now press upload, what do you think is going to happen? So our serial port is ready to send. We've got a whole string of zeros. If I press the button, that's weird. It's not counting by ones. We've got so much data here. You'll also notice this is coming out really, really fast. I'm going to press the reset button on the board, which is the red dot in the corner near the USB. Reloads. Serial port has gone back to 0. It's not counting by 12s. If I press and hold the button, it's almost like it's working faster than I can press. So let's go back into our loop and think, how do we normally do this? Well, we put a delay. How fast do you think you can press and release a button? I'm going to say I can probably do it in 1/4 of a second or 250 milliseconds. So delay 250. Let's see if that helps. Upload. Okay, so it's going a lot slower now. If I press the button, you can probably hear it clicking. But it's not being registered every time. So having a delay is not going to be the most useful solution here. If I press and hold it, it counts. But a short count, it can miss. A short press, it can miss if it's not at the right time. So let's have a think. What's this loop doing? Well, the loop is reading the switch. It's then If the switch is currently pressed when it reads it, it's adding 1 to count. If it's not pressed, then it's doing nothing, and it's then printing out the value of count. It then goes to sleep for 1/4 of a second. We could possibly make the sleep time shorter. Now I'm not getting pulses being missed, but I'm getting multiple pulses, multiple counts, if I press too slowly. If I do a double click, it's not being particularly helpful. Sometimes it's counting, sometimes it's not. So we need to think of a way of debouncing. So we need to come up with a different way of counting our presses. So having a standard delay isn't going to be very useful. What we're going to do instead is we're going to use another variable. We're going to put a variable up here, which we're going to call int switch state. And our switch state, we're not going to define it to start with. And we're going to have another variable called last switch state. And we're going to set that to begin with as low. So by having our two states, we can now know what state the button is currently in and what it was previously. I'm just going to initialize it as low because that will help us work out what's going on. We're also going to need a delay, a debounce time. So we're going to need 2 of them. Now, we could do this in seconds, but we're actually going to use milliseconds. We're going to use a different type of variable. So these are going to use what are called longs. So an integer can only hold up to, these are 8-bit integers, can only hold a number up to 255. If we want to go bigger than that, and 255 milliseconds isn't very big at all, we are going to use what's called a long. Now, we could use a long, but that will count all the negative numbers as well. We only care about positive numbers, so we're going to make this an unsigned long. And we're going to give it a name. Let's call it last time. And we're going to set it to 0 to start with. And we want something called a delay. The amount of time that we're going to pause before we do anything else. So let's set, this is in milliseconds. So let's set unsigned long. What should we call it? DT for delay time. And let's set that to 100 milliseconds. Right, we can change that value later. So what we're now going to do is we're going to go into our loop. Our setup here is perfectly fine. What we want to do is we're going to, instead of doing the digital read inside our loop, let's do it separately. And let's put that into a variable, which we'll call current switch equals digital read switch. Integer current switch, digital read switch. So if when it comes through here you're holding down, then that will be registered as a high. Current switch will take on the value high. If you're not holding the button down, this will be read as a low. Current switch will be read as a low. Now, what we're then going to do is we're going to say if the current switch reading, current switch is not equals, so exclamation mark equals, the last switch state. Well, if the current switch does not equal what it was, then we know it's changed. So if it has changed, we're now going to start the timer. All right, so we're going to make our last time equal. Now there's a function called millis, and it literally reads, it starts a timer that's in milliseconds. Now, that's all we're going to do in that first bit there. What we're then going to do is we're going to give it some time. So if millis minus last time, so what is the current value on the millisecond timer minus what it was? If that is greater than our delay time, our DT, then we can be certain that one, it's been pressed, and it's been pressed long enough that it's not a false reading. So if it's not a false reading, what we can do is we can set the switch state equal to the current state. So then switch state equals current switch. And we know that this is not noisy. Now we can do our count. Count equals count plus 1 or count plus plus. And I'm going to get rid of that. I'm going to leave the serial print line so it can output, and I'm going to get rid of the delay. So just to go through that again, we've set up a whole pile of variables. This is our counter. We're going to have a variable called switch state, which is recording exactly what the current state of the button is, the switch. We're going to keep track of what the last state of the button was. We're going to have our unsigned long, which is going to keep track of the time. And we've got our debounce time, our delay time, of currently 100 milliseconds. We may play with that number in a minute. We set everything up as we did before. And then we're going to say, read the value of switch and put it into current switch. If that current switch is not the same as last time, then start the timer. If the timer minus when it was started is bigger than our delay time, then we know we've definitely got a button being pressed, and therefore we can set the value of the switch state, can add 1 to our count, and we can output our value of the count total. There is one last thing we've got to do, and that is we've got to set the last switch state equals to the current switch state. If we don't do that, it will forget that we've pressed the button. So if we hit verify, that's worked, and we upload. It's counting really, really fast, but it's counting up for some reason. There's been no error, but it's counting. So what we've got is we've got a bit of a glitch in our logic. At the moment we're saying if the delay time has expired, then make the switch state equal to the current switch. So it's constantly flip-flopping. We don't quite want that. What we actually want is we need another if here. So we want this flip-flop only to happen if the current state is not the same as the switch state. So i.e. there's been a change. So we don't only want this to happen if these two are not the same. So we'll put another set of braces in, indent that, and we'll close the brace off. So if millis minus last time is greater than dt, and then if the switch state is different to what we were expecting, then count. So lots of zeros. And it's counting if I press the button down, and it's counting again when I let the button go. So because it's counting twice, it's counting when I go from low to high and from high to low. Well, we only want it to go count when it goes from low to high. So let's make the count only happen if our current state, our button state is high, our switch state is high. So we'll put another if in. If our switch state is high, then we'll do the count. Otherwise we won't. Back to the serial monitor. Pressing down counts up, letting go does not count down. So our Arduino is now running at full speed, but it can only count on an upward pulse. I'm going to press it as fast as I can. But if I press too fast, it can't cope. So to fix that, I'm going to make our debounce time, our delay time, shorter, 50 milliseconds. And now, if I spam it, it can count. The last thing we should probably do is let's see if we can make the LED turn on and off as well. Our LED is still on pin 3. Let's make it turn on if the number of counts is a multiple of 3. So down in this part here, before we do the last, after the last switch, let's add one more thing. Let's say if count. Now, multiple of 3 is a little bit tricky, but if you remember from junior school, you may have come across remainder division. Well, computers can do remainder division. We usually use a slash sign for divide. We're going to use a percent sign for remainder division. 3. So if we take the value that's in count and divide by 3, if it's a multiple of 3, then the remainder will be 0. So what we can say is if count %3 modulo 3 equals 0, then we know that we are in a multiple of 3 situation. So we can then go digital write LED high, else digital write LED low. So this little loop here, this little if, not loop, condition, controls whether the LED comes on or not. So, got a serial monitor outputting lots of zeros. Let's go have a quick look at the board. So 0 divided by modulus divided by 3 is 0. Remainder 0. So it's on. Press the button once. 1, 2. If I press it the third time, 3 divided by 3 is 1 with remainder 0. Comes on. 4. 4 divided by 3 is 1, remainder 1. Remainder 2, remainder 0. 6 divided by 3 is 2, remainder 0. How fast can you make it go by pressing the button? Can you think where you might use a counter like this? There are many situations where counters like this can be very useful. We're going to come back and we're going to have a play with a 7-segment display as a way of being able to count. We'll come back to this shortly.